Alright, hello once again. Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College AWD, or Application and Website Development Program, and in particular the AWD1100 C# Programming Fundamentals course, I've been doing a series of video presentations based on the book we're using for the course, that being Murock's C# 2015. So far I've gone through all of Section 1, the 3 chapters in there, all of Section 2, the 8 chapters in there, and I'm almost smack dab in the middle of the 3rd section. I have done lectures on chapters 12 and 13, so it's time for 14. How to work with inheritance. Inheritance is one of the hallmarks, so to speak, of object-oriented programming. All right, most people, when you think of inheritance, you think of genetic inheritance. And software inheritance somewhat is similar, though it's not the same thing. All right, if you have two people who get married, and let's say you have husband A who has a big nose, and wife B who has a big nose. They get married and they have a child. There's at least probably a better than average chance that that child will have a big nose. Now that might not be nice, that might not be fair, but that's the way that it typically is. All right. I unfortunately have my mother's father's hairline and also my father's hairline, which means that, I'd say in my 30s, my hair started to leave the top of my head. It's just the way it is. So, if mom A marries dad B and they have child C, and child C has a big nose, what can they do about it? They can live with it. They can get a nose job. It's not like they can take that nose off and put another one on. But you sort of can do that with software inheritance. And let's start there. So we've got one applied objective. Use any of the features of inheritance that are presented in this chapter as we develop our C# application. And we have 7 knowledge objectives. Explain how inheritance is used within the .NET framework classes and how we can use it to set up our own classes. Explain why we might want to override toString equals and get hash code methods. Describe the use of protected and virtual access modifiers. Describe the use of polymorphism. Describe the use of the type class. Describe the use of explicit casting, and distinguish between abstract classes and sealed classes. So, if you look at this picture here, I believe at least what the author is trying to show is that if I create product maintenance, if I create a product maintenance class that has a form in it, new product, and that form inherits from, meaning it'll be a colon there, form, that means it gets all this stuff for free. So the form class itself has all of this. So notice, so does the child. But the child can add new things. The child can also do what's called override things it gets from the parents. So in other words, the child automatically gets this close method. But if the child doesn't like it, it can override it to make it do something that it wouldn't normally do. All right, so they're showing here the inheritance hierarchy for form classes. And you can see that control is a child of object and it's a parent of button base, group box, label, list control, text base, and scrollable control. You can see that button, checkbox, and radio button are children of button base. You can see that combo box and list box are children of list control. Text box is a child of text box base. Container control is a child of scrollable control. And form is a child of container control. All right. So these are things right here that you see on the screen that you automatically get. Every single class that you create inherits directly or typically indirectly from the object class. Everything is a child of object. Remember back in the days of DOS, and we talked about there being a root directory that was at the top? That's object. An object has defined in it these 8 methods: toString, equals, two equals, reference equals, get type, get hash code, finalize, and member-wise clone. So, if we create this product class, well, a book is a kind of product. Software is a kind of product. All right? And typically when you use what's called an is-a relationship or an is-an relationship, that's inheritance. So for instance, let's say this had been animal up here, and this had been dog, and this had been cat. A dog is an animal, a cat is an animal, just like a book is a product, software is a product. All right? So now we've got product, and we've got these four things. Three of them are members or fields. One is a method. And there we've got it. Looks pretty similar to what we had before. But notice everything that's in here is public. All right? Public means that it's available everywhere. Now, I've given this example in class before. It's not a terrific example, but it's one I'm going to use right now. Now, I realize what I'm about to tell you, it's not the way life works because of the society that we live in. But technically, since Donald Trump is President of the United States and he is a public figure, I should be able to go to the White House. I should be able to get in there, knock on the door, and say, President Trump, I'd like to have a meeting with you. Now, that doesn't work. It doesn't work like that, and I understand that. But the point is, since he is a public figure, he should be available to everyone who is his public. All right? Then we've got protected. So if something is public, if I make a class public, and I make everything in that class public, it's available to anyone and everyone. If I make something protected, it's available in the current class I'm in and in any descendants or children. But that's it. If it's internal, that has to do with the current assembly or where I'm currently creating my project. Protected in current internal is the current class, derived classes in the current assembly, or derived classes in other assemblies. Typically, you don't monkey with these very much. And private, meaning it's only available in the class you're in. So notice to declare a subclass, as it says there, it's the name of the subclass, colon, the name of the parent or base class. These go by a lot of names. Subclass, superclass, child class, parent class. There's a lot of different names that they go by. All right? So I go in here and I create a child class based off of the parent's class. If I want to call the parent class's constructor, I can say colon base. All right? Which means basically parent. All right? So notice I can hide a non-virtual method or property, or I can override. Hide, basically, will treat it like it's not there. Override will say, I know you mean this, but I want you now to mean this. So here's a book class. What do we have in here? Well, a book inherits from product. So it gets everything that you see here. So a book automatically has a code, a description, a price, and it has a GetDisplay Text method available to it. But in addition, a book has an author. So that's what's new. So when I call this, all right, I want to be able to set the code, the description, the author, and the price. But the code, the description, and the price are going to be set in the parent class. And I want to be able to override that toString method because by default, the toString only displays the code, the description, and the price, but I want it to also include the author. Hopefully, as we go through this, it makes a little bit of sense. So this is a standard way of overriding. You can also override using a lambda expression. And basically, it's lambda syntax. Technically, I don't know if it's considered a lambda expression or not. All right. 3 versions of the GetDisplay method. A virtual GetDisplay method in the product class. All right, I think that's pretty much what we looked at here. But it's only got the code and the price and the description. Here, we're adding the author because we're overriding it. Now here in the software class, we're also overriding it, but the software class has a version as opposed to an author. So the software class, when we create it, it will look very much like this, except it'll say software there, version there, version there, version, and version. Other than that, it'll look pretty similar. All right, so here's an example of code that uses the overridden method. What does that mean? It gets the code, the title, and the price from the parent. But it gets the author, all right, basically from book. So from product, it gets product code, product title, or I'm sorry, product description, product price, but it gets book author. Software gets product code, product description, and product price. It gets those from product, but from software it gets the version number. Hopefully those all make sense. All right, and we can call both of these, but notice product P, all right, if we're calling book or we're calling software. Here we're saying S equals, so it's a software type. Here we're saying B equals, so it's book type. It's one of those things, and you can see the output here. It's one of those things that make more sense the more you use it. All right? So here's 2 versions of that product, and you'll notice for a book, it has an author. For software, it has a version. And hopefully that just makes sense. All right? Nothing really new here. We've seen this before. Here is an overloaded constructor. We've got a no-arg constructor that does nothing, and a full-arg constructor which sets the code, the description, and the price. All right, again, all stuff we've seen before. Now, public virtual string. All right, let's take a look at that. All right, so I'm going to go out because I want a good definition here. So I'm going to go out to msdn.microsoft.com. Hopefully I spelled that right. And I'm going to come in here and I'm going to search for C# virtual. How about just the virtual keyword? The virtual keyword is used to modify a method, a property, an indexer, or an event declaration and allow it to be overridden in a derived class. All right, so that's what we're saying here. Since this is virtual, it can be overridden. Not only can it be, probably it will be. All right, so there's the book class, and there's our overridden. So when we say virtual, we're telling it here we are overriding it. We can do the same thing in software. Again, we're overriding it. Check my time here. I am at 14 minutes. Let me just go for just a second longer, not too much longer. Here's the code for the maintenance form. Notice a for each here. This is going to give us a list of products. This is the code for a new product form. It says if book is checked, we'll know we'll have to set the author. And we're also setting the tag. All right. And we're going to have to now add to our validators to see whether or not the author or the version number have been added. The author, again, if it is a book, the version if it's software. Let's stop right here. We'll pick it up with the type class in just a couple minutes.